You know how everyone's worried about AI and data centers gobbling up electricity like there's no tomorrow? Well, we're burning through power to train ChatGPT, generate images, and run all these amazing AI tools. And honestly, it's becoming a real problem for our power grids. But here's the wild part. What if those same energy-hungry data centers could actually help stabilize the electrical grid instead of just draining it? Sounds impossible, right? Well, researchers at the University of Michigan just figured out how to do exactly that. Let's set the scene. Modern data centers are packed with these incredibly powerful computer chips called GPUs. Each one can use as much electricity as running 7 regular computers at the same time. Now multiply that by thousands of GPUs in a single building, and you've got yourself a massive power consumer. The problem is, when all those GPUs suddenly kick into high gear or dial down, it causes the voltage in the local power grid to swing up and down. And that's bad news. Too low and equipment doesn't work properly, too high and things can get damaged. Normally, we use these slow mechanical devices called tap changers to fix voltage problems. But they're like using a sledgehammer when you need a scalpel. They take half an hour between adjustments, and by then, the damage might already be done. So here's where it gets interesting. The researchers discovered something clever hiding in plain sight. When AI models like ChatGPT process your requests, they don't handle them one at a time. They group them together into what's called a batch. Think of it like a restaurant kitchen. You can cook 1 burger at a time, or you can throw 10 burgers on the grill at once. Cooking more at once is more efficient, but it takes longer for each burger to be ready. The same thing happens with GPUs. Bigger batches mean the GPU works harder and uses more power. Smaller batches mean less power, but also less efficiency. And here's the kicker. You can change the batch size almost instantly. The Michigan team built a system that constantly monitors the electrical grid and adjusts these batch sizes in real time. When voltage drops too low, the system automatically reduces batch sizes, the GPUs use less power, and voltage bounces back. But here's the really counterintuitive part. Sometimes the grid needs more power consumption, not less. Like when there's tons of solar panels pumping energy into the grid on a sunny day, but not much demand. In that case, voltage goes too high, and the system cranks up those batch sizes to soak up the extra power. It's like the data center becomes a sponge that can absorb or release power on demand. Now, you might be thinking, okay, but what about the people actually using these AI services? Nobody wants their ChatGPT to slow down just because the power grid needs help. And that's the beauty of this system. It's constantly balancing 3 things: keeping the grid stable, keeping response times fast enough for users, and maximizing how many requests the data center can handle. It's like juggling 3 balls at once, and somehow it manages to keep them all in the air. In their tests, this approach reduced voltage problems by over 99% compared to traditional methods. And it did it without making the AI services noticeably slower for users. So what does this mean for the future? Well, imagine a world where data centers aren't just tolerated by power companies. They're actually wanted because they help keep the lights on for everyone else. We could build more AI infrastructure faster, integrate more renewable energy into the grid, and maybe even avoid some expensive power grid upgrades. The data center becomes part of the solution instead of part of the problem. Pretty neat, right? Alright, that's it for this episode of the R&D Lab, but before you go, we want to hear from you. Do you think we should be designing all our major power consumers, like data centers, electric vehicle chargers, even factories, to actively help stabilize the grid, or are there downsides we're not seeing yet? Drop your thoughts in the comments below. And if you enjoyed this episode, smash that like button and subscribe to the channel so you don't miss our next deep dive into cutting-edge research. Until next time, stay curious.